Hello everyone. Now that we are done with ridge regression, the next one which comes in the queue is decision trees and random forest. But what I'm going to do is I'm going to put this thing on hold for a second, not for a second, for this time, and I'm going to directly jump to Elastic Net. Why is that so? Because Elastic Net is something which comes next into the regression family after lasso and ridge regression. Okay, so I want to continue the sequence. That's where I'm trying to jump to the Elastic Net directly. Now let's talk about the Elastic Net Regression. Before that, let's do a quick recap about lasso. Lasso is something which penalizes the sum of the absolute value of the coefficients. That's why it is considered to be more aggressive towards the feature selection. Wherever the features which are contributing less to the model building or model training, it does zeroize the coefficient of those features. While if we talk about the ridge regression, it penalizes the sum of the squared coefficient, which means it does not zeroize the coefficient of the features even if they are contributing lesser to the models. That's what mostly it happens. So it is considered to be less aggressive compared to lasso and turns out to be more effective, but that completely depends on the situation when you are applying this. Now consider about a situation where you want to have a combination of both of these two. That's where you're gonna come up with Elastic Net Regression. So Elastic Net Regression simply combines the features of the lasso and ridge regression and gives you the most efficient way of doing the feature selection or model building, whatever. Here we are talking about the feature selection. We will focus on that only. Now if you want to understand this in absolutely layman term, so consider yourself as a coach who is trying to build a cricket team. Now considering in that situation, if your goal is to have the expert batsman, expert bowler, everything is most expert, then that is something where you should be going with lasso. Now if you are the coach who is trying to have the sort of players who could not be an expert but good enough for that, and they have some other qualities as well. For example, somebody is good in batting and can do the bowling also, all those kind of things, it means you are little lenient, then you can go ahead with ridge regression. Now if you are someone who want to have the combination of both of these two, means you want expert of batting, expert of bowling, and some set of features who can do both of the things, or maybe they are not expert but they are good enough, then you should be going with Elastic Net Regression. Hope this clarifies the concept of it. Now because we are not getting into the model building, I'm not going to get into the mathematics behind all of this concept, and directly going to take you to the Python and show how you can implement this Elastic Net Regression and do the feature selection. So let's jump to this Jupyter notebook over here. Here what you should notice is, here I have already imported all the dependencies. Now this is something which we need to do to utilize the Elastic Net. This is how we import the Elastic Net in a nutshell. So Elastic Net comes under linear model module of sklearn, right? So this is how you can do the import. Now this is how I have done the data import. This data has 31 columns, out of which one column is the target feature and the rest are independent features which will help in prediction. Okay, now I'm going to, first thing which I'm going to do is scale this data. To scale this data we require standard scaler, which we have already imported over here. Now to scale this, the instance which I would be creating is, let's say, scalar. Instance is created. Next one is do the fit transform, scalar dot fit transform, and inside that I need to supply my independent features, and this is how scaling is done. I need to store that in the x scaled variable. You can name it anything, whatever you want. Next thing which comes is train test split. So I will do the train test split, and for that, to copy the syntax, I'm going to get into this detail, and from here I will copy this syntax detail right from here, and I will just put it over here. Do a little bit of cleaning into this, and here x which we have, I'm going to replace that with x scaled. Now our train test split is done. Next thing is training our model Elastic Net. So before that we need to create an instance for that. So I'm going to say Elastic Net, and inside that few of the parameters which we need to supply, which I'm going to mostly keep as default. Alpha equals to 0.1. Then I'm going to keep L1 value, L1 ratio as 0.5, and random state I'm going to keep as 42. So this is something I would encourage you to go ahead and try to put different values and see how the performance gets changed. But for now I'm going to keep it almost default thing. If you would see over here, it is alpha 1.0, but I'm keeping 0.1, right? Let's just try it with this one, elastic reg. I'm going to name it as elastic reg, and let's just try elastic reg dot fit, and inside that I'm going to use xtrain, which is my data, scaled data, and white rain. This is done. Now let's just find the coefficient of it. Elastic reg dot coef. Here we got the coefficient of the features. Now let's just try to put it in the form of data frame against each of the features, right? So for that I'm going to say feature importance, let's just say it, and over here I'm going to say feature comma coef for feature comma coef in zip. I'm going to take the list of columns from here, x dataset, all right, x dot columns comma this elastic reg dot coef. This is what I'm going to do, and then after that I'll try to put this in a data frame. Let's say importance data frame. I'm going to say importance df, and over here I will say pd dot data frame, and inside that this is the data frame I'm using, and for that I need to supply the columns parameter into that first column. I would say it is features, and second column is coefficient, or let me say importance, and let's just try to print this data. Ooh, this is what we got over here, right? You see, let me just try to sort this data. I would say sort values. I'm letting it do the autocomplete. Oops, it turns out that it is going to take long, but still I would require to wait. I'll pause the video. Alright, here we got this suggestion. Now I'm going to choose this thing, and inside that I'm going to say by importance. Let me just put it over here, and here I'm going to say ascending. Oops, again I did the autocomplete. Ascending equals to false. Let's see how it goes. Yeah, so here we got this set of features. These are the set of features which the model is considering to be the best fit for our model training. So this is how you can utilize the Elastic Net for the feature selection. I hope it was clear. Just in case of any doubt, put that into the comment section. I'll definitely try to help you out. Until then, happy learning.